topic. Two different special kinds of triangles, isosceles and equilateral, are the ones that we're going to talk about today. The first three definitions in this box are things that we're going to be able to use in our proofs. The other three are just kind of like random things that we'll be able to use when we're looking at a pair of triangles and trying to find X or Y or whatever. But these first three, definitely you want to highlight these. These are our newest proof reasons. The first one is the definition of an isosceles triangle. So sometimes in a proof, my proof statement will literally say, prove triangle ABC is an isosceles triangle. In order to do that, we use this definition, and by definition, an isosceles triangle is a triangle that has at least two sides congruent. So if it says, prove a triangle is an isosceles triangle, you first have to tell me that that two sides are congruent. We can also go backwards. So if it's saying triangle ABC is an isosceles triangle, prove to me that these two sides are congruent, we can do that using the definition of an isosceles triangle to say, hey, these two legs are congruent. That's all this says. Some vocab for isosceles triangles. Isosceles triangles have a lot of vocab for some reason. We saw this on the quiz on Wednesday. Vertex angle is the angle that's like on the top of our Christmas tree. It's the one that is not congruent to the other two. We have two base angles. They're the two angles that touch the base. And we're going to find out in a second that those base angles are congruent to each other. And then the last part are the legs. The legs are the two sides that are congruent. Any questions on any of that vocab? Just some random vocab you might see about isosceles triangles. Okay, two more proof reasons that are kind of the same thing but backwards. The first one says, if two sides of a triangle are congruent. So I'm starting with, I have a hypothesis. Two sides of my triangle are congruent. Let's say this one and this one. Then I can say the angles opposite those sides are congruent. That's my conclusion. When I say the angles opposite those sides, I am referring to the base angles. So in this isosceles triangle, if I know those two legs are congruent, the two base angles touch the base, right? That's the base right there. So hypothesis conclusion, I started with two legs congruent. I end with base angles congruent. I can use this in my proofs. My proof reason states two sides congruent. Remember that arrow means implies. Two sides congruent implies base angles congruent. That's all we got to use for our proof reason. Now we can also go backwards. So this is the same exact thing, except I'm going to state it the other way. My hypothesis is if the base angles in a triangle are congruent, so I'm starting with these two being congruent, then the two sides opposite those angles, aka the legs, are congruent. And again, kind of the same thing, but backwards here. Base angles congruent imply two sides congruent. These are our three big new definitions here because we can use them in the proofs, but they're not all that we're going to learn about today. Any questions on these three, though? Some more kind of self-explanatory ones. I think we've been waiting to see this one. This one says, if a triangle is equilateral, then it is equiangular. So if, again, hypothesis, a triangle is equilateral, I know all three sides are congruent, then conclusion, it is equiangular. I know all three of these angles are the same. Hey, wait a minute. What do I know about equilateral in equiangular triangles? What are the measures of those three angles every time? Dahlia. Perfect. I know that they're all 180, and if they're all the same, 180 divided by 3 is 60 degrees. The next one is the same thing but backwards. Hypothesis, A triangle is equiangular. All of these guys are 60 degrees. Therefore, in conclusion, it is equilateral. So if I know all the angles are the same, then I know all the sides are the same. Again, these two we're not using in a proof. That's why there's no proof reason statement up here. Those are just things that we would use to find x in a triangle or something like that. The last one is kind of a weird one. I'm going to draw you a picture here. Stay with me. My hypothesis states, if a ray, line, or segment bisects the vertex angle of an isosceles triangle. So there's a couple of things that need to be true here first for my hypothesis to work. Number one, I have to know already that this is an isosceles triangle. By definition of an isosceles triangle, literally its core definition right up at the top of your page, all I have to know about this triangle is that two of the sides are congruent. So that's the first part of my hypothesis. Then it says, a ray, line, or segment bisects the vertex angle. Your vertex angle is up at the top, opposite the base, and I'm going to draw a line down through the center. It's bisecting that angle up at the top, which means, by definition of an angle bisector, those two pieces are going to be congruent, those two angle pieces. That is all the setup. I haven't even said anything special yet. I have to have all of these conditions be true first. Okay? The top angle is being cut in half, and the two sides are congruent. Then, we can say, in our conclusion, it is also the perpendicular bisector of the base of that triangle. Perpendicular means what? What does perpendicular mean? Caitlin? So these two angles right here are right angles by the perpendicular part. And then what does it mean if it bisects this base? What is bisector? Dahlia? Yeah. So a lot of setup just to say, I know that those angles are right angles, and I know that those two pieces of the base are congruent. Again, not something you're going to see in a proof, but something that you might see in a problem where it's find angle X or find the length of this side, right? Any questions on that? Okay, let's look at some examples. Nice and easy examples at first. For example 1, I'm finding the values of X and Y. What we're looking for in pretty much all of these problems is where can I use isosceles triangle properties? Where can I use equilateral triangle properties? If I take a look here, I see two different triangles. I'm going to start with this one right here. I see that the two legs of this triangle are congruent, so that tells me that the two base angles must be congruent. That's my isosceles triangle property number 1. If I have two legs congruent, it implies base angles are congruent. So if that's 50, this is also 50. Then to find X, all I got to do is 180 minus 50 minus 50. That X should be 80 degrees. Right? Nice and easy. I'm not doing anything crazy here. I'm looking for isosceles triangles. Same thing happens in the triangle on the right. Here's my isosceles triangle. I know it's isosceles because these two legs are congruent. That also tells me these two base angles are congruent. So if that one's Y, this one is also Y. So Y plus 100, 100 equals 180. Y must be 40. That's it. Nothing crazy. Look at number 2. A little bit weirder. Okay, our diagram looks different. What do we think we can tell about this diagram? Look for those isosceles triangles. What do we know? Anybody? What if I highlight one? What does this triangle having two legs congruent tell me about these two angles at the bottom here? Presley. They're equal to each other. So do we know what their measurement is, or can we pretty easily figure it out, right? I know they all have to add up to 180, and I know that the top one is already 40, which means these two must add up to 140. 180 minus 40 is 140. So each is 70 degrees. Doesn't help me find x or y yet, but I can now figure that out pretty easily, can't I? What's y? Casper? Perfect. This is a linear pair, so y must be 110. Maybe do we start to see another triangle that's isosceles in here? If that y is 110, how do we find x? Or what is x? Casper? It is 35. 180 minus 110 is 70. I need to divide 70 by 2 because I have two congruent base angles. That's 35. Questions on that? Flip it over. Okay. Weird one for number 3. I need us to remember that this is what my setup looks like for this last property. I have that line through the middle. I have the two angles at the top that are congruent. I have the two sides are congruent. That's like the most basic setup. So what I need to know about this problem right here is that it looks the exact same. I have an isosceles triangle because these two legs are congruent. I have this line down the middle that is bisecting that angle, the vertex angle. So then what do I know about angle x? Casper? It's 90 degrees. This is a perpendicular bisector. So that x is 90. Beautiful. Okay. Number 4. Nice, easy one. What's y? Casper. Perfect. All three sides must be congruent because all three angles are congruent. What about x? Go ahead. How do you know it's 120? So what is this angle right here? So if that's 60 and they form a linear pair, then this must be 120. Good? Okay, I love this problem. Let's talk about this circle. In the diagram, O is the center of the circle, AB is parallel to CD, ABO equals 24, and OBC is congruent to OCD. Find BOC. So I have a circle here. I have a lot of things to highlight. I'm going to first highlight that these two sides are parallel. I know that this angle right here is congruent to this angle right here. And the angle that I'm trying to find, I'm going to give it 2 tick marks and a question mark, is that one in the middle. I see a triangle in there. I'm going to try to use my triangle properties to help me fill in some information about this guy right here. What's special about this problem is that it's in a triangle. So that tells me something. If O is the center of my circle, and these go to the edge of my circle, OB and OC, what does that tell me about these two sides right here? In a circle, what would we call those, Casper? Yeah, they're radii of a circle. And so in a circle, shouldn't the radius be the same all the way around? So can we say that these two sides are congruent to each other like so? Turn that triangle sideways. What does that tell us about the angles of that triangle? Any ideas? What kind of triangle is that? It's isosceles. It's an isosceles triangle, which means the base angles must be congruent. So look at that. I have 3 angles here that are all congruent. Can I call those angles? Pick a variable. Let's just call all 3 of those x. Are we okay with that? In order to figure out what that angle in purple with the question mark is, I need to know what angle x is. So now let's talk about those parallel lines. If I highlight these parallel lines, think back to Unit 3, use your Unit 3 thinking hats. What am I going to do here? Do we have a transversal I can use? I think so. It's got to go through both of those lines, so this is my option for my transversal. What is my transversal getting me right now? Look at where those angles are. Here and here. What kind of angles are those? Casper? Same side interior. What do we know about same side interior? They're supplementary. They add up to 180. So let's make an equation where I add those 2 angles together to get 180. I'm going to take the top angle, which is 24 and x. The bottom angle, which is x and x. And they equal 180. So I can figure out what x is. 24 plus 3x equals 180. 3x equals 156. Is that right? 156. Divide by 3. I don't remember what x is. 52. So if I zoom out here, this triangle that I had originally, I'm trying to find this angle. Ooh, hello. I know that this one is 52 and this one is 52. What's that angle that I'm missing? About 76. Any questions on that one? Ooh, that was a lot of thinking. Okay, are we ready for proofs? Now that our brains are a little bit fried from that circle problem? Okay, take a look at letter A. I am given angle 1 is congruent to angle 2. First corresponding part. Highlight it. I could just go right into my second given. I don't know why they did it in this order, to be honest with you. I would just keep going through your givens in order. BC congruent to DE. That's our second given. Here and here. Now I have to look at my diagram and I have to find a third thing. So I think about my go-tos. Reflexive, no. Vertical angles, no. Don't have any parallel lines. I'm thinking about isosceles triangles now. That's going to be like one of my next go-tos that I go to. Do I have an isosceles triangle in here somewhere? Where is it? Yeah. The middle one is an isosceles triangle. So I could say that if I know that those 2 legs are congruent, I know that 3 and 4 are congruent. But is that going to help me prove that those 2 triangles on the sides are congruent? Where else do I have an isosceles triangle? Think big picture here. Anna. ABE. The entire triangle is an isosceles triangle. So if I know that this entire triangle is an isosceles triangle because those 2 base angles are congruent, I now have a theorem or a reason that says, well, I can prove that AB and AE are congruent. Do we see how we kind of have to make a decision there about what we're actually going to put in here? There's a lot of stuff with isosceles triangles going on. Our reason for that is because I knew angles 1 and 2 were those base angles that are congruent. And base angles congruent imply 2 sides are congruent. So now I have 3 parts. My final prove statement, like I said earlier, is to prove triangle ABC is congruent to triangle AED. Those are these two triangles on the outsides here. So I now can prove that those two triangles are congruent. I have side angle side. Any questions on that one? This last one's a little weird, so stay with me here. Letter B. I am trying to prove that triangle VYW is isosceles. I highly recommend you start by putting that proof statement at the end because it's going to give you a kind of like direction of where to go. Where do I need to start? VYW is isosceles. Think about what that means. If I'm trying to prove VYW, this triangle in the middle, is isosceles, what do I need? What information am I trying to get at? By the definition of isosceles, what two things would make this isosceles? Caitlin. So, kind of. Our definition of isosceles only talks about sides, though. So all I want is that VY and WY are congruent. So I know that that's going to be here in step 5. Literally, the definition of isosceles, two sides are congruent. So you see how I'm kind of working up backwards right now to kind of see where I'm trying to go? So now let's go back up to the top. Let's take care of those givens. I know my first given is here. Let's highlight X, Y, and ZY. That's here and here. I know my second given is 5 congruent to 6 here and here. So what's going to be my second reason here? Any ideas? Dahlia? 1 and 2 are congruent. Why do we know? Two congruent sides imply base angles congruent. Let's write that out. 2 sides congruent imply base angles congruent. So then what's in step 4? I got to bridge the gap here. This is still a triangle proof. I'm still following the usual steps of my triangle proof. I have sides congruent, angles congruent, angles congruent. So in step 4, I have to say, put it all together. I need to put it all together and say that these two triangles are congruent. So step 4, always pretty much step 4, right, is triangle XVY is congruent to triangle ZYW. That has not changed. Once you get your 3 corresponding parts that are congruent, you say your 2 triangles are congruent. I'm not changing that step. Our reason, AAS. Once I know that those 2 triangles are congruent through angle, angle, side, think about my logic. How do I know VY and WY are congruent? Anna. CPCTC. I can say any other part of those 2 triangles are now congruent because I know that the triangles are congruent. And then number 6, how do I then know that that triangle is isosceles in the middle? What tells me something is isosceles? We were working our way backwards to get there. Any ideas? Caitlin? Perfect. Definition of an isosceles triangle. Perfect. Any questions on that?